Okay, so this is actually another example. You notice that this example is actually a series circuit in a parallel branch. So maybe you would like to pause at this point to try answering the questions over here. Okay, so as mentioned earlier in the previous video, you need to first find out any one of the unknown, okay, based on the R equals to V over I. So if you have V, you have I, you can find R. You have R and V, you can find I, and likewise you have R and I, you can find V. So in this question, EMF is 12 volts, R2 equals to 3 ohm, R3 equals to 4 ohm, and R4 equals to 5 ohms. You know that because it's parallel branch, so EMF across V2, okay, EMF across V2 is the same as, the PD across V2 is the same as the EMF, and the PD across R3 and R4 is also equals to, in total, 12 volts. Okay, so since you are given all the resistance, and in the question over here you have to find R total, you can actually find it very easily. So you realize that R total here is actually equals to 1 over R2 plus 1 over R3 plus R4. Okay, so that gives you 1 over 3 plus 1 over 9. Alright, okay, so you will then have this 3 plus 1 over 9. Okay, so in other words, you actually have 9 over 4, and that equals to 2.25 ohms. Okay, so you have the first part. Part B, you are asked to find the value of A1. So A1 is actually the total current, right? Because you notice that right from the battery, the first place that it goes to is A1. So there's no split branch at that point. Therefore, A1 must be the total current. Because this is actually functioning like a series at that point. So the answer would then be actually A1 is actually equals to EMF over R total. So that gives you 12 volts, right? 12 volts divided by 2.25 ohms, and that will give you 5.33 ohm to 3SF. Okay, so next we want to find out what is A2 followed by A3. So actually, since we already know what's the total current, and we know this is actually a parallel branch, what we can do, there are actually two methods in this case. Alright, so the first one is actually to use this. I2 is equals to R1 over R1 plus R2 times I total. So basically what R1 is, it's actually 9 ohms. Okay, so 9 ohms over 9 ohm plus 3 ohms. Okay, multiplied by I total, which is 5.33, and yeah, okay, 5.33, and we will calculate what the answer we have. We will have about 3.9975, which is approximately 4 ampere. Okay, so alternatively, there's another method. So the alternative method is actually, because we know what is V2 and we know what is actually R2 as well, so we can actually have 12 volts divided by 3 ohm, and that gives us 4 ampere as well. Okay, so next we talk about part D. So part D is A3. So A3 is actually equals to A1 minus A2, because you know that this is actually parallel branch. So with that, total current is 5.33 minus away 4 ampere. So you will be left with 1.33 ampere. So that's for A3. So right now you're asked to find V2, V3, and V4. We know that V2 is actually equals to EMF, which is equals to 12 volts. Alright, because it's actually parallel to the battery. So it's equals to the EMF. Okay, whereas for V3 and V4, the total must be 12. Okay, and so at this point we can actually use the potential divider rule. So V3 is actually equals to R3 over R3 plus R4 times V total. So that will give us 4 ohm over 9 ohm times V total of 12 volts. Alright, and that will give us approximately 5.33 volts. Okay, so the next part, if we want to find the V4, we can actually just use 12 volts minus 5.33 volts, and that will give us 6.67 volts. So all this is actually up to 3SF. Okay, alternatively, you actually know that you already have the current, right? You already have current of A3. So A3 is 1, so V3 is equals to I3 times R3. So you have 1.33 times 4 ohms. That should give you the same answer, approximately the same answer. So this is actually about 5.32 volts. Okay, and if you use the similar method, okay, V4 I4 times R4, okay, you will get 1.33 times 5 ohms, and that will give you 6.65 volts. Okay, so you notice that actually for these two values, they don't end up as well as the other one. So that's because we actually round off the current, right? But these are the methods in general to solve the question.